All right, welcome to PyCSE again. Today I'm going to talk about functional approaches to iteration, and we'll look at a few examples of how to do that. We use iterations like for loops and while loops to repeat code, sometimes conditionally, and we can do a lot of things with that, including accumulating values like a sum or a product, or adding to a list. And so we'll look at a canonical example first. Let's say we want to create a list that has x squared for the first, say, 5 integers. One way we could do that looks like this. We make an empty list to accumulate for I in the range of 6. Then we can accumulate I squared. And here we use plus equals and rely on the fact that if you add two lists together, it just concatenates them. And here we're concatenating I squared, and range will go from 0 up to, but not including 6. And if we look here at the value of A after we run this, then you'll see that we have the first 5 squares. Now, a downside to this approach is this variable I is sitting in your namespace. So it has a value, and it's the last value of the loop. But if you had previously used I for something, then it would have gotten clobbered by this. So a nice way around this is to do the following. We can use a list comprehension. So let's say x squared for x in range of 6. This is going to give us the same list of numbers, the first 5 squares. But now x is a hidden variable, and if we look at its value, then you see we get a name error because it doesn't exist. And it doesn't exist because that variable is hidden inside the scope of the list comprehension, and it never actually gets out. So you can have other variables called x. Now, a functional way of thinking about this would be that we write a function. Let's say def square takes a variable x, and let's return x squared. And here we're going to now use map. So map is a Python functional approach to doing iteration, where you provide a function, square, and we're going to apply it to every value in the range of 6. Now this is going to generate a generator, an iterator an iterable of its own, and so to actually see, we have to cast it as a list, and now you get all of these. So you can think of map as a one-line way of taking a function and applying it to every element in a range or in any iterable, and this function can do whatever you want in here. We just do it like this. Now suppose we want to go one step further and only do this for the even numbers. Let's do it for the odd numbers. So let's do this only for the odd numbers. In that case, we still might, let's go back and see what this looks like before. For I in range of 6, now we have to say something like if I % 2 is not equal to 0, then we will do a plus equals I squared. And now a should be the odd numbers squared, I think. So we see 1 squared, 3 squared, and 5 squared. Okay, so this is getting, you see this extra indenting. So let's look at a list comprehension way of doing that. So in list comprehension, we might say x squared for x in range 6 if x mod 2 does not equal 0. So that's just rewriting in a shorter syntax with the list comprehension like this. And what we can do with filter is combine filter and map. So with filter, we have to provide a predicate function. So let's go ahead and write that. Def odd p of x, return x %2 not equal to 0. All right, and then we'll start out by looking at a list of the filter of odd p and range 6. So this should give us just the odd numbers 1, 3, and 5. And then we can do map square onto that. And that is again giving us a generator, so we have to put it here to actually see what it is. All right, it's debatable whether this is more readable than this. It's somewhat of a style of whether you like functional programming and whether you need functions. You can do a lot of interesting things there. All right, the last one that I want to talk about is reduce. So reduce is in Python 3 no longer in the core, it's in functools. So we have to import it. And reduce is an interesting function. It takes a function and an iterable and then accumulates something in it. So let's say we wanted to do a sum. So let's do the sum of range of 5 in old-fashioned explicit loop. We might have a variable that starts out at 0 and then say for I in range of 6. A plus equals I. All right, and that would give us 15. Of course, we can also just do sum range of 6, I think. That should also give us 15, like that. So this is another not quite functional way of doing it, but this sum is doing the same thing as that. There is not really a list comprehension equivalent of this because we're not trying to make a new list, we're trying to reduce by some operation. So to do this in a functional way, we're going to write a function. Let's write one explicitly. Def add a comma b and return a plus b. And then what we want to do is call reduce with add and range of 6. And this is giving me an error. Oh, didn't I run this? I'll probably have to run that. And now we can see what this result is. We get 15. Now we don't have to define this function here. You might also just use the built-in one that is an operator. And then you don't have to define that yourself. So that brings me to the end of just a brief introduction to map, filter, and reduce, and ways you can use that to eliminate explicit for loops. One reason you might do that is we're not telling the computer how to do this, and there may be optimizations behind the hood that can take advantage of parallelization or multi-cores. That is up to the library to figure out how to implement this. In contrast, up here we're telling it exactly what to do and how to do it, and there may not be the same opportunity for it to figure out how to do this in an optimal way. If you want to learn more about iteration, I just published a new supplement over at pointbreezepubs.gumroad.com on iteration, and it covers for loops, while loops, comprehensions, and some advanced topics like the one I just went over. We have sections on the for loop, composite iterables. This includes zip and enumerate. We have while loops and all the variants of break, continue, and else. We have a couple of pages on different kinds of comprehensions and some advanced methods on breaking out of nested loops or conditional statements using NumPy arrays to avoid some kinds of iterations and loops. And this last part, functional programming, has also a little section on iter tools that you may find helpful. All right, so thanks for listening. Hope you find that helpful. You can find the link to that Python iterations supplement in the description. And if you like it, leave a rating or a comment, and make sure you follow our channel here to get notified when we have new videos available. All right, thanks. Have a good weekend.